student. Today's video we are going to learn optical detectors in fiber optic communication. I am Bhagyashree Thora and welcome to my channel Pinnacle. So first we have to understand fiber optic receiver is an electro-optic device which accepts optical signal from optical fiber and converts them into electrical signals. This is very important. The next question is optical detector is consisting optical detector, then amplifier, signal processing circuit. Why we require this? Entire circuitry and control circuitry. Basically, optical detector is consist of optical detector device and entire signal processing circuit, which is convert optical or light signal into electrical output. This is a block diagram of fiber optic receiver. If you want a optical detector, which is a main block in optical detector block diagram, so it is actually a transducer. It is a transducer that convert optical signals into electrical signals. We know that transducers are devices that convert input energy of one form into output energy of another. In our case, optical detector is generating electrical current. That means it is output proportional to the intensity of the incident optical light because input is optical light. So optical detector is a transducer which is converting electrical current proportional or which is generating electrical current proportional to the intensity of the incident optical light. So this is working of optical detector in one line. Next question is, if we are using this optical detector or a transducer in fiber optic communication system, then what is the requirement or what characteristics we want? First is fiber is like a hair. So whatever circuit or whatever device we are going to connect in fiber optic, the size of that device, it should be efficient for coupling and packaging. This is very important because if the size is too much large, then we can't couple or package optical fiber, wire or cable to optical detector. Then second and very important is the wavelength is dependent on the source. Okay, wavelength is dependent on source and it is high sensitive. So the detector should be high sensitive for the wavelength. Means if we are having a three windows for optical fiber 880, 1310, 880 nm, 1310 nm and 1550 nm. So for these three windows, that detector should be sensitive. Third and very important criteria is low noise contribution. And fourth one is maintain stable operation in changing environmental condition. Means if the temperature or humidity changes in environmental, then the detector characteristics should be stable. So the first option is for detector is semiconductor photodiode. Generate current when they absorb photons. Now the amount of current depend on first thing wavelength of light and responsivity of photodiode. The first and very important is the wavelength and next is the responsivity. Then the third parameter is size of photodiode active area relative to the fiber core size. That means if this is my fiber, okay, then this reflective area, it should be broader for photodetector. This is my photodetector, okay, and this is fiber. So this area, active area, it should be brought to fiber core size. And very important is alignment of fiber and photodiode. So this fiber is properly aligned in photodiode. then only entire light is going to incident on my photodetector. Otherwise, there is a leakage, and this is nothing but a loss in my fiber optic communication system. Now, how many materials are available as optical detector? So first is the silicon, gallium arsenide, gallium aluminum arsenide, which is used for first window 850 nm. Okay. Then germanium, indium phosphate, indium gallium arsenide. It is used for 1310 nm and 1550 nm. These materials actually determine the responsivity of the detector. Now, what is responsivity? So, responsivity of a detector is nothing but a ratio of output photocurrent to the incident optical power. Okay, so responsivity is equal to output photocurrent divided by incident optical power. It's function of wavelength and efficiency of the device. This is very important because if incident of power is very high but output photocurrent is low, that means the device is not efficient. That's why the efficiency of the device is a function of wavelength. The next photodiode is a PIN. So PIN is a semiconductor positive negative structure with an intrinsic region sandwiched between the two regions, and this is very important that normally it is operated on reverse bias voltage. Okay, and the third and very important thing is a dark current, because when we are using photodiode, then in a normal condition there is a incident of light which is not from fiber, and because of that the leakage current is there, and this leakage current is known as a dark current. Okay, so this is a structure that is a P region, this is intrinsic region, and this is N region. This is anti-reflection coating because when we are connecting fiber, so then we don't want back reflections of light. Okay, and the core is properly aligned in a detector. Okay, because of that the electrical current is generated and it is proportional with the incident of light on photodetector. So this is a structure of PIN photodiode. Response time of a photodiode is depend on these four characteristics. The first one is a thickness of active area. Okay. Then second one is amount of time required for the electrons generated to flow out of the detector active area. Then third, detector RC time constant, and fourth, capacitance of photodiode and resistance of load. So this is schematic of photodiode. The photons are going to incident on intrinsic area. Then there is a holes and electron combination. Load resistor is there, and in that load resistor current is going to flow. Okay, and these are the how in a market the photodiode is available. So these are the different photodiodes are there. Now, what are the advantages of photodiode? The first thing is the output electrical current is linearly proportional to the input optical power, making it highly linear device. This is very important. Okay, this is a linear device. Then low bias voltage, less than 4 volt, low noise, low dark current, and high speed response. These are the advantages of PIN photodiodes. The cost is also low. And in your laboratory, in experimental setup, we are having PIN diode only. Remember that. Okay, because PIN is having a low cost. The next is the avalanche photodiode. So normally when we want amplification of photocurrent or in a noisy condition or long distance, then we are using APD. It is also a reverse bias voltage. Okay, reverse bias condition APD is working across active region, and the gain of APD can be changed by changing the reverse bias voltage. Okay, so when we want amplification, then we are using avalanche photodiode. So this is the structure of avalanche photodiode. Again same thing, anti-reflection coating, incident of light, fiber is going to attach here. Okay, N region, electric field, and P region. So here amplification takes place. In the next video, we are going to study the detailed characteristics of photodiode, performance characteristics, and PIN and avalanche numericals. If you are having any doubt regarding this, then please comment. And if you like my video, then don't forget to like and comment. Thank you.